Welcome back, physics fans. Here we go for quiz number, I think it's 14 off of the Moodle website on static equilibrium. And it's a uniform 300 kilogram beam of length 4.8 meters is held stationary by a horizontal cable. The cable is attached to a point on the beam 3 meters from the hinge. The beam forms an angle of 40 degrees with the wall as shown. And if the maximum cable tension the tension in the cable that can withstand is 12,578 newtons. Wow, look at that precision. What maximum mass M can be suspended from the end of the beam? Okay, free body diagram. We have a force of gravity of the beam, force of the center of gravity. We have force of gravity of block M. We have a horizontal cable that's called the tension. And we have a force at the hinge. Okay? And my guess is, I know it has to be up because there's only downward forces, so there has to be an upward force. And there's a left force, so there has to be a rightward force. So my guess is probably something like that. Okay? But since it's a guess, you're obviously intuitive enough that I'm going to put the pivot point there. Because I have no idea which direction that and which magnitude that force of the hinge is. Okay. The center of gravity, I'm now going to ruin my free body diagram by writing some stuff in it. It's mg, and that's in my case, it's 300 times g, 9.8. So that's going to be 2,940 newtons. And this tension is told to be that it's 12,578 newtons. That's as big as it can go. So what forces do I have? In yellow, I have that force. I have that force. So definitely I'll put the pivot point at the hinge to get rid of the hinge. Therefore, I can get that force by the sum of the torques. The torques have to equal 0. But to do the torques, I need the angles. So if this angle here is 40 degrees, then this angle here is 50. So this is 50. And this angle here is 40. This angle here is 40. And that's where people will go wrong. Let's just zoom in 200%. See those angles. Okay? 40 here between the radial arm, that radial arm, boom, to that location where the force is, and the force of gravity is a sine of 40. And this mass will also be a sine of 40. But this tension will be a sine of 50. Okay, let's zoom on out. Okay, so now it's just one equation. Sum of the torques have to equal 0. The torques counterclockwise has to equal the torques clockwise. So the torque caused by the tension has to equal the torque caused by the force of the center of gravity plus the torque caused by the force of gravity of the mass. The formula is force times distance times the sine of the angle, and then all the torques are that. So this is actually going to be the tension, not just a force, it'll be the force of tension. And that is going to be 12,578 newtons. The length of the horizontal of the beam is 4.8 meters. And the cable is attached 3 meters from the hinge. So that distance up is 3 meters. So this is a 3 in my case. And then it's going to be a sine of 50. And that has to equal the force of the center of gravity, and that is going to be 2,940 newtons. That's halfway up the uniform beam, so it's going to be 2.4 meters, and times the sine of that angle, which is 40, plus the torque caused by the mass at the end. And that's going to be the force of gravity of the mass times the distance, which is 4.8. And I need to slide on over a bit. How about I do the old grab and slide here? I don't need that much room. I just need to put the sine of 40 here. Okay, I'll just put the plus sign in a big red and the equal sign. Where does this all come from if you're kind of missing it? It's these three forces. The tension, let's highlight it in blue, I'll just undo it. The tension is counterclockwise, and this force cause torques in the other direction, and then I just have to balance them out. Okay, now it just becomes a math question at this point. Okay, so 12,578 times 3 times the sine of 50. The torque counterclockwise is 28,905.9 Newton meters. And that has to equal the two torques by the others. So that is going to be 2,940 times 2.4 times the sine of 40. 4,535.5 plus. So really, I just subtract these two, and that will be this value of that torque, the torque caused by the mass. So the torque caused by the mass is just the subtraction of these two forces, torques. And this is just going to be force of gravity of the mass times those two numbers. So take that number, subtract that number, finish there, boom, boom. So we get 24,370.4 Newton meters is the torque caused by the mass, which is equal to the force of gravity of the mass times 4.8 times the sine of 40. And the mass is just going, the force of gravity of the mass is just going to be mg. So I take this number on the calculator and divide it by 9.8, divided by 4.8, and divided by sine 40, and I'll be just left with the mass. So take this divided by 9.8, divided by 4.8, and also divided by the sine of 40, and that will leave me my mass. The mass of the largest mass that could be on there without breaking the cable is 805 oh my gosh, 0.99 or 806. And that's going to be units as kilograms. Thank you for watching and enjoy it.